So today what we're going to do is we're going to look at our parabolas when our a value is less than 0. So as you can see here, we currently have the parent function y is equal to x squared on the screen, and we're going to compare it to what happens when our a is a negative number. In particular, the first one we're going to look at is when our a is simply -1. And as you can see here, what happens is we have what is known as a vertical reflection. So this is a vertical reflection, sometimes called a reflection over the x-axis. The reason it is sometimes called the reflection over the x-axis is because our horizontal axis, the x-axis, is what this is actually being flipped over. So our parabola is flipping essentially from being top to being on the bottom now. Now, most of the features of our parabola are actually not changed, because our axis of symmetry, for example, if I open up x is equal to 0, is still the same. It still cuts both of the parabolas right down the middle. And in addition to that, our vertex of 0, 0 is also still the same. Now you may be saying, well, hold on a moment. How am I going to graph this now that it's on the other side? And the truth is, our 1-3-5 rule that we've been using to generate a bunch of points to graph this actually still applies exactly like it did to the previous one. So we need to multiply the 1 and the 3 and the 5 by our a value, and that'll tell us we need to move -1, -3, and -5. And if we look at our graph here, well, if we go 1 over and down 1, that gives us our first point, and also the corresponding point on the other side. We move 1 over and down 3. That gives us our second point and the other point on the other side. And if we move 1 over again and down 5, that gives us another point. So in truth, having an a value less than 0 doesn't actually significantly change our parabola outside of flipping it to the bottom half of our graph here. It went from being on the top half to being on the bottom half. And if we vary our a values, and we're going to go ahead and show another graph, if we vary our a values, you're going to find that it will still work just the same. The only difference will be that it will be either skinnier or wider on the bottom instead of on the top. So let's hide this graph for the moment, and now we're going to show this one. It is in blue. Whoops, I made the wrong one disappear. It's in blue on the bottom there, and it has a is equal to -1. So it's just like our previous one, green over blue. It's still the same thing. But now we're going to go ahead and make our a value vary. So as our a value gets farther away from 0, so it gets even deeper into the negatives, as you can see, it's approaching -5. This is just like how our a value, when our a value got bigger, when it was bigger than 1, like it would go towards 10 and 20 and 30, it behaves the same way. The graph gets more narrow. And what is happening here is actually two transformations at once. Not only are we reflecting it, doing a vertical reflection, we're also doing a vertical stretch. So this vertical stretch and the vertical shrinks work both ways, regardless of what side of the axis we're on. To give you a comparison, if our top function was instead going to be y to the 5x squared power, and our bottom one is our a value is -5, you'll notice that the two graphs are actually identical. The only difference is one of them has been flipped vertically. Outside of that, there's still the same narrowness, so our vertical reflection still works in the same way. Anyway, back to the parent function. And if we make our a value between -1 and 0, so we go back and we're back to -1, so this is just a mirror of our parent function now. If it's between -1 and 0, as you can see, it too becomes wider. So it's just like what we had before. This time, however, we have a vertical reflection and a vertical shrink. A vertical reflection over the x-axis and a shrink of a factor of 0.1. So the negative sign, the only thing it does is it flips it over the x-axis. Everything else, all the other things, I shouldn't say it's the only thing it does, but almost everything else is the same. But there are actually some critical differences between the two of them that will manifest themselves. But in terms of actually doing the graphing, outside of it opening down, it's very, very similar. It's the same process as graphing it as if it opened up. Even if you weren't sure it was going to open up, or even if you thought that it would open up instead of down, you just graph the points and realize, oh, it's actually going down and not up this time. But there are some critical differences. And the first one actually relates to our vertex. So our vertex is 0, 0. Before our vertex, and you can see the vertex on our parent function, y is equal to x squared, that vertex is the lowest point on the red parabola. On our blue parabola, you can see there, though, the vertex is actually the highest point, or the maximum value. So while our domain remains the same, so our domain is still all real numbers, aka, in case you've forgotten that funny looking R symbol, our range is actually different. And this time our range is actually less than or equal to the x value, excuse me, the y value of our vertex. So our domain, our range this time, and I should label it as being range, our range, rather than being y is greater than or equal to 0, is now y is less than or equal to 0. So this is something that I imagine is relatively straightforward for you to see, because we start at our 0 over here at our vertex. Every value of our y value, as you can see, just gets lower and lower and lower. It goes farther and farther away from 0. So we're down at around -5 now. We keep going, -6.7, and it just keeps going down and down and down forever. So now we have a maximum value at our vertex. So our range is going to be y is now less than or equal to 0. The or equal to is, of course, because our vertex is included. So it's always going to be or equal to. It's just a matter of, will it be greater than or equal to when our a is bigger than 0, or less than or equal to when our a is less than 0. Now, the other important thing that has changed relates to our increasing, decreasing. So if we were looking at our parent function, on the left side over here, we have 10 up here. And as we approach our vertex, we're going down. So that's the decreasing portion. So the left side is decreasing. But then once we hit our vertex, we start going up, our y values start getting bigger. And this is our increasing portion. So previously what we had was decreasing and increasing. Now the opposite is going to be true. Now we have increasing and decreasing on opposite sides. And if we were to drag our point along our graph, or the marble as I like to imagine it, the marble is going uphill, so our y values, they're getting smaller. Are getting smaller in magnitude. They're getting closer to 0, but 0 is our maximum. So the fact that the negative numbers are getting smaller is actually means that they are increasing, because 0 is bigger than all the negative numbers. So as we're approaching our vertex, as we slowly approach our vertex, we're increasing. And likewise, when we move farther away from the vertex on the right side, we're getting more and more negative. These means our numbers are decreasing. Don't forget that negative is like debt, and being in debt is bad. So the more debt you're in, the worse it is. So that's decreasing. But as we approach 0, that means we're increasing. But as we get further from it, we're decreasing, because 0 is our maximum value. So those are really the two major differences between these two types of graphs, when our a value is greater than 0 in red or less than 0 in blue. the increasing, decreasing swaps directions, and the way that we write our range goes from being a greater than or equal to in our red graph, because everything is greater than 0 on the red one, to being everything is less than or equal to 0 on our blue graph, because everything falls below the 0 outside of our vertex. Outside of that, basically everything else is the same in terms of actually doing the graphing, but the shape is significantly different, and you have to worry about there being both a vertical reflection and a stretch or shrink. As shown here, the blue graph currently shows a vertical reflection and a vertical shrink of a factor of 0.1.